This is the solution video for the Quadratics and Cubics revision worksheet. So the first question, we want to figure out the value of t and the value of k. There's two ways that we can do this. We can first of all recognise that we're looking at a perfect square and use that to get our solution. If we go about it this way, that minus 6x is the key to figuring out what goes into our brackets. I've left a blank at the end where the t should go. I'll fill that in a second, but I can see that this position here should be filled by the term minus 3, and that's because with the perfect square, the first term is squared, so that's x being squared. The second term is the first term by the second term by 2, and then the third term is the square of the last entry in the bracket, giving me plus 9. So I have my t and my k. So that's one way to do it. Alternatively, I can do it using identities, in which case I should square out my x plus k squared bracket, and then I should equate like terms. So x squared equals x squared. I'm not going to find anything out from that. Minus 6x equals plus 2kx. I can just write the coefficients of those down. That's going to allow me to find my k value of minus 3. And then equating my constants t equals k squared, I'll be able to use substitution to find t. Either way is fine. The second question, I want to solve simultaneous equations. So here I've got one linear and one quadratic equation. I'm going to start by rearranging the linear, and that's going to allow me to replace the y's in the quadratic. I'm going to multiply out this quadratic equation then, and I'm going to tidy it up into a more familiar looking quadratic. Don't be afraid to use an extra line there in your expansion of your brackets. And when I tidy it up a little bit more, I'll get my quadratic in the correct order. I can actually divide this across by 2 if I like to make it a bit nicer. This is actually factorisable, but the numbers are quite big, so if you wanted to go off and use the minus b formula, you could. In any case, it'll factorise to give 5x minus 9 by x minus 3, leading to my two solutions, x equals 9 over 5 and x equals 3. Don't forget, you also have to get the y value, and you can get that by going back to your original linear equation here. So I'm going to sub in the 9 over 5 first of all, and I'll get minus 13 over 5. I'm quite happy to leave that as an improper fraction. And then I'm also subbing in my other solution for x, and I'm going to come out with y equals to 1. So if you want to, at the end of that, you can write each set of solutions as a point, so that you're pairing up each x with the relevant y. On to question 3. This is just a question asking you to identify the nature of the roots. So let's have a look at what's going on here. We've got 3 different diagrams, and we've got different interactions with the x-axis in each case. In the first diagram, we've got 2 intersections with the x-axis, meaning 2 distinct real roots. In the second diagram, we've got 1 point where the curve intersects the x-axis. So actually that's 1 repeating real root, or 2 equal real roots if you like. And in the last case, there's no intersection with the x-axis, so there are no real roots. I've got complex roots instead. Remember, in some questions you might be asked to do a calculation to decide which of the above cases that you're dealing with, and in that case the discriminant b squared minus 4ac is going to be useful, because you're going to find that it's greater than 0 in this case, equal to 0 in this case, and less than 0 in this case. In question 4, we're looking at a cubic. I'm going to set up the array for this, but first I'll find a root by inspection. 1 will work, and if x equals 1 is a root, then x minus 1 is a factor. Now we go to the array, and I'm setting up my array with my factor x minus 1 on the outside and the first and last terms from the cubic inside in the array. And then I'll proceed to complete that. So I'm going to put x squared here to make the x cubed on the inside. Minus 1 by minus 11 is going to go up here. I'll fill in these boxes then. Minus 1x squared minus 11x. I want to get minus 9x overall, so I need a plus 2x in here to bring me up to that. And I want a minus 3x squared, so I need a minus 2x squared to go together with the minus 1x squared to make that. And then I'll fill in my last box up here. So minus 1 by minus 2x will give me plus 2x. And that also works for the top row of the array. So now I've got my quadratic factor. If I could factorise this, I'd go ahead and do so to get the remaining roots, but actually I can't do that in this case, so it's minus b formula. And then I'm going to fill those values in. And just note in the question they want any irrational solutions in surd form, so I don't need to go too mad on the calculator. I'll just type this in and see what I get out. And leaving it in surd form, it's just 1 plus 2 root 3 or 1 minus 2 root 3. So I'm going to list out now all my roots at the end. And that's question 4 completed. On to question 5, we've got a surd equation. It's a pretty straightforward one. The thing to watch out for with these guys is that you make sure to verify your solutions at the end. So I'm going to start by getting rid of that root. I'm just going to square both sides. And by now it's pretty obvious it's going to be a quadratic. I'm going to factorise that and solve. So now verifying my x equals 3 first of all, I literally just subbed 3 into the original equation. 3 equals root 9, I'm happy with that. Subbing in the minus 2. Minus 2 equals the root of 4. We actually don't, in these particular kinds of questions, accept negative roots. So the root of 4, if it was plus 2, fine, but because the root of 4 is given as negative 2 here, I'm not going to accept it. That means my only valid solution is x equals 3. Finally, question 6. We want to write the polynomial out in full. First of all, we'll identify its roots. So notice that I'm going through the x-axis at minus 1, 1 and 2. Notice that it's bouncing off the x-axis here. The x-axis is a tangent, so this is actually a repeating root. And it's also worth having a look here at another point, our y-intercept in this case, and it's minus 4. So I'm going to expect that when all this is multiplied out, that's going to match the constant e at the end. So I'm writing out all my roots, and then I'll write out my factors that go with those. Notice I've written x minus 1 squared because I've got x minus 1 by x minus 1. And I'm also in front of those factors going to put in an a to account for my constant factor, because there can just be a number factor without an x as part of a polynomial like this. I'm going to multiply this all out. I'm just going to keep the a out in front. And you'll notice that when it's expanded in full, I'm getting a minus 2 here at the end. Now, if I compare that to my y-intercept, which is minus 4, clearly they don't match, and they should. So that's my way then of figuring out my value for a. What would a have to be in order to give me the correct value here? Okay, so what would I multiply by minus 2 to get minus 4? Clearly that's 2. And then I'll simply just multiply across by 2. And there's my full polynomial. Again, I've done that expansion on a separate piece of paper in this case, actually, not in my head. But I would say for yourself, show all the steps of your expansion when you're doing a question like that. You're better to kind of include as much as possible rather than make a mistake along the way.